All right, so let's talk about the two types of waves that you need to know for this class. The first type of wave is called a transverse wave. And transverse waves are what you're going to conventionally think of as a wave. Transverse. Like if I said, imagine a wave, transverse is what comes in mind. Transverse waves are waves that oscillate up and down while they move forward. Or to put it, it doesn't actually have to be up and down. The key idea is that the oscillation goes one direction, and the direction of the velocity of the energy is at a right angle to that. So it could be side to side while the wave moves forward or whatever. But the idea again is that it crosses. That's basically what trans means, is cross. So it's a crossing wave where the oscillation of the particles is at a right angle to the velocity of the wave itself. So transverse waves, there's lots of them that exist in our world. Probably anything that's like an ocean. I'm just writing the word wave. That's helpful. Ocean waves, at least the ones that you see, are basically transverse waves. Um, or the parts of the waves that you see are transverse waves. Other examples of transverse waves include, even though this doesn't come up in our class, light is a transverse wave. And then the last example of a transverse wave, gosh, I just had it in my mind. Oh, if you have a spring or a string or something like that, and you're going up and down, that's definitely going to be creating a transverse wave. The next type of wave, and this is the harder type of wave, is called a longitudinal wave. Uh, Longitudinal waves, the oscillation of the particle is along the direction of the particle. So you can think of this as an example of like the kind of wave that travels through a material that has been hit. When you hit it, it sends that compression through the material, and then eventually the other side is going to vibrate out slightly. That's kind of like if you see a slow motion video of somebody getting punched in the face, you will see transverse waves move across the surface of them, but the longitudinal wave travels through them, and it's what causes the movement eventually. In fact, any movement is actually based on a longitudinal wave. A popular thought experiment of a way to travel faster than the speed of light is the idea of making a meter stick, or a stick that's a light year long, or more than a light year long, and then you push one side, and the thought is, well, the other side's going to instantly move because you pushed it, and by doing that, you've actually sent something faster than the speed of light because you caused motion information to be sent faster. But that's actually not how it works. If you pushed on the side of that meter stick, it would compress there, and it might compress quite a bit of it, but it's actually going to send a compression wave moving up the meter stick or whatever that would move at some speed lower than the speed of light. So longitudinal are these compression waves, and the most important example of them is a sound wave. When Mr. Terrell talks, or anybody talks, what's happening is they are creating an area of pressure, of pressurized air, and those air molecules smack into the next air molecules, causing them to now move forward. And as they smack into the next air molecules, we get more compression. And then if they move this way, and then they slam into more, and so these ones move forward, they eventually slam into more, and we just send a wave of compression, compressing waves toward compressing air towards people, and that becomes sound. So longitudinal waves, the big idea there is sound. In both these waves, depending on the type of graph that you're given, you can figure out wavelength, amplitude, yada yada. But even longitudinal waves are often drawn to look like transverse waves. Usually what they'll do, though, is that they will graph it so that we have the high pressure, and then they have the low pressure area. And then it will just say, as we go from this area where the waves are close together, we would have high pressure. Then we get to that next area, the pressure would be low. Then the pressure gets high again, and then it gets low again, right there, or rather there. So then we would just have a graph that looks like this. Now, this actually isn't a graph of position versus time. This is a graph of pressure versus position. So it looks like a transverse wave because we can see the kind of like up-downiness. That's a science word. But in reality, this is a longitudinal wave. So those are the two different waves that you need to know about. Transverse, again, are made by oscillating something back and forth, which sends a pressure wave outwards from that location. Longitudinal wave is done by hitting something and then it just compresses all the way through there. So there you go, types of waves. Thanks for watching.